Critical points. Hey, students, do critical points come from the first or second derivative test? First. Okay, they do. Now this says analyze the critical points. So I'm just going to show you guys another way to look at critical points and actually use a second derivative to help you figure out if there is a max or min. Okay. What does the second derivative tell us about a function? It tells us about the inflection. No, inflection points. What else? What else does the second derivative tell us? Concavity. Tells you about concavity. Now, here is concave up. Okay, that's a concave up. And here is concave down. Okay, there's 4 different ways to draw a curve. I just showed you the 4 different ways. One is concaving up. One is concaving down. In the concaving up, one part is decreasing, one part is increasing. One part is increasing, one part is decreasing for the concaving down. Okay. Now, if you have a critical point tells you that the slope at that point is equal to 0. So, let's look at a max. No, let's look at a min first. Here's a min. That point right there has a slope that equals 0. Now, since I'm in calculus, I shouldn't write m anymore. I should say f prime equals 0 right there. Now, how would I know with the second derivative that that is a minimum? Because it's concave up, right? It makes a lot of sense. It's kind of obvious. I hope it's obvious. Here's a max. The slope right here is equal to 0. This one is concave down. So I can say f prime is less than 0. And this one, no, I'm sorry, dang it, that's concave up. You just told me that too. And f double prime right here is concave down. So if I get a negative number for a critical point in the second derivative, we know that we're concaving down and that it's a maximum. All right, so let's put this into practice. Let's find our critical points for this function right here. We have f prime is going to equal 5x to the 4th power equal or minus 20x to the 3rd power. All right, we set this equal to 0. We solve. We get let's see. We'll get 5x. We'll take a 5x to the 3rd out, and we get an x minus 4. All right, we have our 2 factors. Now we can use the 0 property. X equals 0 and positive 4. So we have 2 critical points at 0 and positive 4. If we were actually to graph this thing at 0 and positive 4, we know that we have a slope of 0. But, hey, could we use a second derivative to see if it's a max or min? I mean, before what we would do is we would go like this. We would draw a little sine line graph. We put a 0 right here. We get a 4 right here. And we go, oh, is it plus or minus right here? Is it increasing, decreasing right here? Decreasing? Okay, we could do that. This is possible. You can do it this way. But I don't want to do it this way. I want to use our second derivative just for the sake of learning here. So let's take our second derivative. We have our second derivative equals, let's see, second derivative of x, second derivative of f of x. Okay, we got, what was that, 20x to the 3rd minus 60x squared. Okay, what happens if we plug in 0? We plug in 0 to f double prime, we get 0. What happens when we plug in 4? Oh, it's a big number, huh? Let's see, we get 20, and then 4 to the 3rd power is 64, minus 60, and oh man, those are big numbers right there. Is that going to be a positive or negative number? So this is 1,280, and what is 60 times 16? 960. Okay, and is that positive or negative? This is positive. Positive number. Okay, so at 4, do we know if it's a max or min? At 4, do we know if it's a max or min? At 4, we're concaving up. So when we're concaving up, we have a min. You guys got that? You see what I wrote right here? This is like golden right here. This is like these are the little cheat sheet right here, the legend. Okay, at 4 we have a min. Okay, at 0 we have a 0. Oh dang, that is inconclusive. That's why this says the second derivative test is inconclusive. We don't know, just by the second derivative test, if we have a max or min right there. So now we have to go back to our sine line graph. Does that make sense? And so we would plug in a number before the 0, plug in a number after the 0, and plug those into the first derivative to see like if it's increasing or decreasing, to find out if there's a max or min right there. And that's how you use a second derivative to determine if a critical point is a max or min.